Hi, this is Samuel Pokoo, a doctoral student of California Intercontinental University. In this presentation, my topic is visualizing hypothesis testing. My agenda for this presentation is in 5 main headers. I'm looking at visualization 1, test for a mean, visualization 2, comparing 2 groups, visualization 3, efficiency comparison, and visualization 4, correlation testing. Then I'll end this presentation with very key important takeaways. Now let's begin with the test for a mean. That's our visualization 1. In the test for a mean, we'll be looking at the research question and then a null hypothesis and an alternate hypothesis. But there's one thing I want to establish. For a null hypothesis, the population mean equals hypothesized mean. So in a test for a mean, the null hypothesis indicates that the population mean should equal the hypothesized mean. Now the alternative hypothesis in a test for a mean indicates the population mean differs from the hypothesized mean. So having established that, let's go to this our particular test for a mean research question. Now read. On average, are the widgets from Acme Widget Company defect-free? So based on our earlier assertion on the null hypothesis and alternative hypothesis, insofar as this test for a mean is concerned, the null hypothesis is that the widgets from Acme Widgets Company are not defect-free. They are not is bold in the presentation to represent emphasis. So in the null hypothesis, I repeat, the widgets from Acme Widgets Company are not defect-free. The alternative hypothesis for this research question is that the widgets from Acme Widgets Company are defect-free. The R is bolded for emphasis. Our second visualization test is comparing 2 groups. Now, in these 2 groups, the research question is, does the average major league team have more home run hitters than its corresponding minor league team? The null hypothesis for this research question is that the average major league team does not have more home run hitters than its corresponding minor league team. The does not have is bolded for emphasis. Now the alternative hypothesis for this research question is that the average major league team does have is bolded for emphasis, does have more home run hitters than its corresponding minor league team. Now let's go to the third test. Here we are looking at visualization number 3, efficiency comparison. The research question indicates that the efficiency curves of the red and blue teams were recorded. Do the teams have equal mean efficiencies? The null hypothesis indicates that the team do not have equal mean efficiencies. The do not is bolded for emphasis. Alternate hypothesis. The teams do have equal mean efficiencies. The do is highlighted for emphasis. Let's go to the visualization number 4, which is a correlation test. A German study tested how larger industrial vans utilize gasoline. One of the analysis plotted mile per gallon MPG versus the weight of the various vans in the study. After plotting the data on a scatter plot, the researchers performed a correlation test and found a significant correlation. However, they forgot to state their hypothesis test in their published paper. Important question. What were the study's null and alternative hypotheses? Null hypothesis. There is no correlation between the mile per gallon MPG and the weight of the various vans in the study. The no is bolded for emphasis. Alternate hypothesis. There is the or the A is bolded for hypothesis. There is a correlation between the miles per gallon and the weight of the various vans in the study. Important takeaways. We have two key important takeaways for this presentation. We'll be looking at two key ones. They include creating hypothesis tests and using visualization. Under the creating the hypothesis test, the key takeaways include the following. 1. Hypothesis is derived from a research question. 2. A hypothesis always has the dependent and independent variables. Now let's look at the takeaways for using visualization. Visualization aids appreciation. That is, by looking at it, you can tell visually whether you will accept or reject the null hypothesis. Using visualizations helps to prevent error in interpretation. You know exactly where your p-values falls, and interpreting it is easier. On that note, I want to thank all you as a distinguished audience for watching. But before I bring this presentation to a close, I want to find out if there are any questions from any one of you. If there are no questions, thank you very much for granting me audience. See you another time. Thank you.